We are solving some in-text questions. 12.16, write the resonance structure of CH3COO minus, and we need to show the movement of electrons by curved arrows. So CH3COO minus is CH3CO and O minus. So let's write the electrons which are present based on, because it has it's formed only one bond. It is surrounded by 6 electrons, whereas this has only 4 electrons. Now we will show the movement of electrons. So one of the pairs of electrons will move towards here to form a double bond with the carbon, and this in turn will move over here, and this leads to the formation of a single bond with the carbon and with the oxygen, and a double bond with this oxygen atom. The next one we need to write the resonance structures of CH2, CH2, and we need to say which is the most stable of the group. So CH2 double bond CH, single bond COH. Now what happens is the electrons are going to move in such a way that this electron pair will move here and this moves up here. So CH2 positive charge because electron pair, CH double bond, C single bond, O minus H. So the other structure that is possible is when the electrons come to the CH2, and that leads to the negative charge on CH2, and this in turn will lead to a positive charge on oxygen. And between these structures, 1, 2, and this is the second structure and this is the third structure. Between the three structures, the first one is more stable because it has the number of covalent bonds in this case are more compared to the other two structures, and also there is no charges and all the atoms have their octets which are full. Then in the next case, there is structure 3 is going to be least stable because oxygen is supposed to be more electronegative, but it has a positive charge. So because of that, the third structure is the least stable. The second one is has a positive charge on a electropositive atom like carbon and a negative charge on oxygen, so it's relatively more stable than the third one. So the order of stability in this case is going to be 1, which is more stable than 2, which is more stable than 3. In the third question, we need to explain why the following two structures cannot be the major contributors to the real structure of CH3COOCH3. Now the reason this is the case is because they are less important because of the concept of charge separation, which means you have a negative charge on the oxygen and positive charge on carbon in case of the first one, and the second structure, oxygen, which is electronegative in nature, actually is carrying a positive charge, and that in turn will lead to a decrease in stability. And so they do not offer they don't offer a lot of stability towards the resonance hybrid. Now in case of the first structure, you also have a carbon atom which has an incomplete octet, and if you remember when we discussed about resonance structure and the stability of the resonance structures, one of the rules of it, the fourth rule, was that it should have a complete octet. All the atoms in the molecule should have a complete octet, and because of that, the two structures which are given cannot be considered as a contributor to the real structure of CH3COOCH3.